Hi folks, let's talk about natural logs today. Natural logs work the same way as normal logs, same properties, same exponent rules, all that stuff remains the same. It's just got a different base. So normally with logs at a base 10, well, natural log has a base E. We abbreviate natural log as LN. That's because way back when it stood for logarithmic natural, or naturalis, I forget, it's Latin. Anyway, so that's why it's LN, not NL. Feel free to look around on your calculator and find those buttons. Find the E button. E is just a number. That's just the base of natural log. Okay. A couple things for the graph. If you want to graph this in your y1, graph this in your y2. I think I already have it pulled up here. So this is y equals e to the x. This is y equals natural log to the x. They are inverses of each other. So if we were to talk about the domain and range here, the domain for e to the x would be all real numbers, or negative infinity to positive infinity, and the range would be everything bigger than 0. Now for the domain and range of natural log of x, it's just flip-flopped. So this can be 0 to infinity, and then all real numbers, or negative infinity to positive infinity. So same stuff. Y'all want to draw, good pictures and all that stuff, have at it. It's just reflected across the line, y equals x. Okay. Transformation rules for our graph stay the same. So if I have a minus 3, that moves it to the right 3. The plus 1 moves it up 1. All right. For number 3, it wants us to rewrite an equation. So g of x, if I reflect it across the x-axis, that's going to put a negative sign to the x. And then if I'm already at plus 2, I'm going up 1 more. That would be plus 3. And that's it for that one as well. Since we're kind of weird with the e's and we're not too familiar with that, oops, sorry, what's going on with that? We're going to just do a few problems dealing with e's. And then if you want to put this in the calculator to get the final answer, that's cool with me. So exponents, just add them. So e to the 5th, final answer. This one we're squaring everything, so that'd be 9 e to the negative 8 times e squared. Go ahead and add those together, so I get 9 e to the negative 6. We don't like negative exponents, so that's going to be 9 over e to the 6. And really, either answer is good. On the test or quiz, I don't want you to see a number and not know how to put it in the calculator. So be sure you know to where the E button is and where the caret symbol is and where the 5 is and all that stuff. On number 6, log base 7 of 7 was 1. Log base 10 of 10 is 1. So natural log base E of E is 1. So on number 7, we got natural log, and then I want negative E, or sorry, E to the negative 4th. That's base E, so all that cancels out. My answer is just negative 4. Same application here. I got E to natural log base E of 6. All that cancels out. My answer is just 6. So you got to know those properties. It works very similar to how normal logs work. 9 through 12, just know those properties again. Minus means division when we're dealing with logs. So natural log of x over 2 equals 4. Now I'm going to rewrite it as an exponential. So e to the 4th power equals x over 2. Then I'm going to solve for x. I multiply both sides by 2. And so x is going to be 2 times e to the 4th. My recommendation, put it in the calculator step by step, or just leave it like that. Number 10, rewrite it. Number 11, rewrite it as an exponential, put it in the calculator. So e, because it's base e, to the 5.4 is x. Done. Number 11, e to the 3.4825 is equal to x. Where we're getting e from, it's the natural log base. All right. Number 12 is probably the hardest problem on this entire worksheet. We want to get y by itself. So first thing I'm going to do is subtract 7, then I'm going to divide by 3. So I get 3e to the 2y minus 1 equals 3. Then I'm going to divide by 3 like I said. So I'm going to get e to the 2y minus 1 equals 1. Then I'm going to be taking the natural log. That's the weird part. Natural log of both sides. It's just like taking the normal log of both sides, but I'm dealing with e, so I have to do natural log. So when I do that, then I can bring 2y minus 1 in front, then I still have natural log of e equals natural log of 1. Well, we already talked about natural log of e cancels out because that's just 1. So I have 2y minus 1 equals this. Well, this is saying e to the what power makes 1? Well, anything with a 0 exponent equals 1. So that means natural log of 1 is 0. And if you didn't follow that, just put it in the calculator. Natural log of 1 is 0. So now I'm just solving for y, add 1, divide by 2. So y is 1/2. So there's no way we would have been able to get down to y equaling 1/2 if you didn't know to first isolate that and then to use our property rules and use the exponent property to be able to move that in front when you have natural 1. Okay? Last thing is a couple different applications. We're using the PERT formula, which is anytime we have compound interest being compounded continuously. So we use the PERT formula so that the A is the end amount. I don't know on number 13 what the end amount is, but I know the beginning amount is $1,000. My E is just E. My interest rate, I do know, excuse me, it's 5%, but we don't do that. We do 0.05 because we're dealing decimals, and then after 10 years. So we're just going to put that whole thing in the calculator. I think I have it. I'll go back a second. Oh, right there, yeah. 1,000 E to the 0.05 times 10, you get 1648.721271. I would round it to decimal places because we're dealing with money here. So 1648.72. And then number 14, kind of work backwards because we want to end with $1,000, but we're starting with 750. I know my interest rate, but I don't know my time. So the first thing I'm going to do is divide by 750, so I get 4/3 equals e to the 0.08t. It's going to work just like number 12 did. I'm going to take the natural log of both sides. So I have natural log of 4/3 equals a natural log of e to the 0.08t. Bring that in front. So natural log of 4/3 equals 0.08t. My natural log of e goes away because it's 1. Then we divide by 0.08. Divide by 0.08. I think I have this in my calculator. Yep, 3.596. There you go. And that's years, so we're okay with your decimal places. All right. Good luck, guys. We'll catch y'all later.